All right. So I want to thank the Idaho Technology Council and David for putting this together. We'll just do some real quick introductions here. My name is Ryan Doty. I'm with Cerium Networks, and I lead a team of technology professionals locally that help both commercial and public sector organizations get the most out of their technology investments. Cerium Networks, we've been here in Boise for 14 years, a little over 14 years, and we're partnered with leading manufacturers such as our friends here from Cisco, as well as Dell Technologies, VMware, Microsoft, and others. Prior to this, I worked in the virtualization space with a focus on compliance, specifically PCI. On a personal level, I'm from Detroit, and I am first and foremost a sometimes sane single dad to an awesome teenage son that attends Boise High in the room next to me. I spent the better part of a decade active duty in the U.S. Army doing a job called technical escort. What that means is I help lead a small elite team, rapid response team comprised of bomb disposal technicians, EOD, as well as nuclear, chemical, and biological warfare specialists responding to threats all around the world. It's a pretty wild time. I'm also a founder of a local charity called TechQRF. We're a group of Treasure Valley technology professionals that use our expertise in technology and our network to solve problems for nonprofits and those in need. Stoked to be here in Idaho. I'm part of this amazing community. I often tell people I'm not from Idaho, but man, I got here as fast as I could. And I am also an avid but terrible golfer. With that, John, if you want to introduce yourself.
Am I back? I'm back.
Welcome back.
Yeah, I'm John Rice. I'm Technical Solutions Architect, TSA, EIEIO. I've been lots of different types of three-letter acronyms, so this is the latest one. Been in the industry as, I was mentioning a little bit before, as you can see from my hairstyle and my beard style, for about 40 years. So I would tell my kids when I would go to their career days that, I've been in computing since before PCs. And most, of course, kids can't remember anything before an iPhone. So, that really blew them away. But anyway, I will do one last thing here. I've been with Cisco for coming on 10 years. And I have one last thing to show you here to establish credibility. Anybody know what these are?
Yes.
Oh, I didn't know you had those.
I have a punch deck. The first program that I wrote in college a lot of years ago, outside of a class. And I tell people, this is working code. I could put this on GitHub nowadays and make a lot of money out of it because it worked. It was a Valentine to my then girlfriend who became my wife. So it is working code. If you want a copy of this, I'll put it on GitHub for you. So anyway, I've been with Cisco coming on 10 years, always data center, and looking forward to talking about hyperconvergence with you guys.
That's amazing, John. Pono, please.
All right. First off, can anybody hear me? Oh, excellent. All right. I cannot hear myself. That's probably a good thing with my air traffic control headset on. Good morning, everybody, or aloha. My name is Pono Wong. I am the data center specialist for Cisco. I am a recent arrival in Boise, moved here, 7 weeks ago from Portland, but originally from Hawaii. And what I'm enjoying about being here the most, well, there's two things I enjoy a lot. First off, it reminds me a lot of Hawaii. Okay, not the lack of ocean part, but the idea that from a community standpoint, people are genuine. They seem to be genuine. They seem to be kind and very helpful. So it's a lot like being home. And then the second one is I live in Eagle, and it takes me about 3 minutes on my dirt bike to get from here to the nearest trail, and then I can just go as far as I want. So very much enjoying being a part of the community here also. My history can't beat John's, although I've been at this for a while. Originally, graduated high school when I was 17, joined the Air Force, had a great 4 years as an armament system specialist on F-15s. I didn't have to dispose of them. We just put them on and let the pilot get rid of them. And after that, I was in the maintenance and parts, and then eventually thought I would really like to work indoors on a computer with air conditioning. That would be nice, and that's how I ended up in this industry. So 23 years doing this, all through all sides of technology sales, started in distribution, and ended up becoming a reseller, and then have been since at Cisco, Dell, and EMC separately. So lots of data center experience. I'm open to, in Hawaii, we call this talk story, which is basically we just sit around, talk to each other. My hope is that as we roll through this, it becomes more of an interactive session than just a one-way presentation. That's what I'm accustomed to, and it feels like that's what the culture is here in general. So with that said, Ryan, I'll turn it back over to you.
Really appreciate it, gentlemen. So yeah, let's dive in, guys. So today we're here to cover the topic of hyperconverged infrastructure. And to kick this off, I'm going to start with a little history lesson on how we got to where we are today, covering the data center timeline. And after that, we're going to look at why we should look at HCI today. And I'm going to be calling hyperconverged HCI a lot, less verbal soup. So why we should look at HCI today, as well as some specific use cases for hyperconverged. And then we're going to roll into some of the prevalent myths around the architecture, answer any questions, and then we're all going to nerd out with John Rice on the technical side of things. So, as I said, we're going to start off. We're going to talk about the data center timeline, right? And you can see what we got here. We're just going to dive right in, guys. So, information technology, way back. Maybe punch card John there. This all started with the mainframe, right? And back then, IBM, they owned everything: hardware, software, operating system. If we can find a silver lining from these days, it's that there was one throat to choke with your technology vendor, right, as it were. And remember that phrase, because we're going to come back to it. Unfortunately, the mainframe era was not tenable for a lot of organizations, right? Your options were massive and expensive mainframes or multiple massive and expensive mainframes. Scaling out back then, it was a pretty painful and costly process. People wanted more choices, and the market responded with build your own data center or siloed infrastructure. This is where each technology is designed and configured independently. Competition in the marketplace helps drive down costs, right? But at what cost? So I think this picture sums it up really well. All the silos are independent of each other. So on the picture, you can see on the left, you got some HP servers. In the middle, you got some Dell. To the right, there's some old Cisco switches. It's kind of an amalgamation of different vendors and technologies, and that's really hard to support. It's going to require specialties in multiple disciplines, which in many cases means requiring multiple teams with disparate skill sets that work independently, right? So it goes without saying that this can be, a nightmare to operate for IT teams of all sizes. It also lends itself to the finger pointing game that we all know and hate, right? Where you got to make 15 phone calls and you're on hold for a month just to have every other vendor say it's the other vendor's fault. And you're just trying to solve a problem. I'm certain a lot of us have been there before. So as it usually does, the market saw opportunity here and innovated to bring us converged infrastructure. So this is what most of us likely know today. It's sometimes called unified or fabric-based computing. It's dominant in the Idaho market and across the industry, right? So components of converged infrastructure might include server, storage, networking, backup, and software for management, automation, and orchestration. So converged infrastructure address the problems that we discussed there with siloed architecture and sprawl by pooling and sharing the resources. The key to remember here with converged is they are validated designs, right? The individual vendors for the networking, the compute, the storage, the backup, they all agree, and they built them together, and they all agree that the technologies will work together. So installation, configuration, day two operations, they've already been tested. And as long as the design is followed, they guarantee that it'll work together. And then importantly, it's all supported as if it's one unit, one phone call, one number to call, really avoids that finger pointing game we were just talking about. So basically, rather than dedicating a set of resources to a particular computing technology, application, line of business, converged infrastructure just creates a pool of virtualized servers, storage, and networking capacity, and it's shared by multiple applications and lines of business. And I got some examples here: vBlock, FlexPod, FlashStack, and there are others as well, of course. So then, in this, we also have hybrid cloud. You can debate where it's going to fit here in these slides. We'll just throw it in here and just touch on it briefly. This refers to a mixture of computing, storage, and services environment, right? Made up of both on-premise infrastructure, private cloud services, and public cloud, like AWS or Azure. And then it's got, again, orchestration between the various platforms. So public clouds like AWS and Azure, right? They deliver cloud infrastructure as a service, right? Everything's as a service nowadays. Gives you really good economies of scale. You know, it scales elastically. They run fully automated, and they're really reliable and redundant, right? I mean, they're massive data centers. Amazon has like 68 physical data centers in the US alone. They're huge, these farms. Microsoft has like 160. So, you know, you don't really have to worry about all 160 of those going down. It's pretty reliable. Of course, as you scale your performance within the public cloud, the cost per hour's fees rise. And if you ever decide that you want to move your data from the public cloud to back on-prem, for example, you know, egress fees can be pretty atrocious. It can be a bit difficult. A lift and shift of most standard workloads to the public cloud, like VMware or Hyper-V, for example, that generally be two to four times more expensive. So it's not always viable for a lot of standard workloads in the long term, even though it's pretty easy. And then private cloud is just you know, dedicated cloud infrastructure for your organization, right? Gives you greater control. Security benefit is the one I want to focus on, right? So your data and your workloads, they're going to remain behind your firewall and your policies, and they're only accessible to your organization. But again, the negatives here, there are higher initial costs for the purchase of the equipment and responsibility for operating and maintaining it. Okay. So that's kind of a brief little history lesson, but now we're getting to the meat and potatoes, guys. So we're going to touch on hyperconverged or HCI at a high level. I'm going to do kind of the 30,000 foot view here. That's why we're all here today. So you remember just a few minutes ago back on mainframe, I said we're going to come back to that one throat to choke. Here we are. So HCI, it's software-defined infrastructure, and it virtualizes all the elements of conventional hardware-defined systems. Okay, so at a minimum, HCI includes a hypervisor, software-defined storage, and virtualized or software-defined networking. And if any of these terms are foreign to anybody, please feel free to stop us at any time, and we can dive a little deeper and explain them. But fundamentally, hyperconvergence is just a way of constructing a private data center that emulates the public cloud consumption in terms of the simplicity, the economic model, and scaling granularity, right? The benefits of that public cloud model on-prem, in essence. So it provides a lot of this, or all of this, without sacrificing performance, reliability, or workload availability that we all rely on today. Okay, so for too long, infrastructure policy and management have focused on the wrong constructs, right? Managing storage and hosts and clusters, that's old school, man. In the post-cloud era, the workload should be the focus, which makes sense to all of us, I imagine. And in HCI, the application is the focus, right? And then if you notice in the picture, they all look the same, right? Just very simple, same nodes that are just stacked on top of each other. And that's kind of what we're going for here, right? One appliance, it's really simple. It all works together. You need to add more, you just add another. You need to decommission one, you take it off. Simplicity in your environment, ease of management. These are hallmarks of hyperconverged. So Bill Gates has some really good quotes. And this one's a nice segue into the next section where we're going to talk about some of the areas that HCI can be impactful for organizations. So onto the use cases for HCI. So over time, HCI has proven itself as an architecture that's viable for even the most demanding mission critical workloads, right? Whereas in the early days, it was typically shoehorned into niche use cases like VDI. I'm getting a bit ahead of myself. I did mention in the beginning that I want to debunk some of the mishaunting HCI, and I do have a slide dedicated to that coming up, but this is a key point, right? Technology evolves and changes. The market demands and it responds. So that may have been the case. Let's not get ahead of myself. Let's just keep driving forward. For adopters today, all that skepticism is replaced by excitement. You can really enjoy these benefits. And let's go back to the early days and we'll work our way forward. Okay, so in the early days, HCI was pushed really hard for certain niche use cases. One of these was VDI, or virtual desktop infrastructure. And it wasn't uncommon to see hyperconverged touted for similar use cases like virtual server infrastructure. And it makes sense, right? HCI collapsed all the hard parts of virtual desktop infrastructure VDI into a single appliance, often with just enough flash storage to help ride out boot and login storms that could plague other architectures. This makes sense, right? This is why VDI was paraded as one of the top HCI use cases at its outset. But technology evolves, right? So let's talk about databases. Databases, they're the workhorses for most businesses. Yeah, they power everything from e-commerce sites, point of sale systems, CRM, ERP tools. I mean, really critical applications. And regardless of what the application is, the databases all have one key fact in common, right? They have to perform because they're usually linked to the bottom line. Poor performance can impact revenue in different ways, could increase expenses if your applications are running slow and you're holding back in employee productivity, or maybe they reduce revenue by driving away customers that are frustrated with the checkout process taking too long. Got to have your databases perform. Hyperconverged solutions, they can support even the most intense database applications thanks to the inclusion of flash storage and the efficiency of storage stack on each cluster node. And that's a key point on why HCI has evolved as much as it has. Flash storage has gotten a lot more affordable, right? So as databases grow, HCI makes it a lot easier for companies to expand their storage footprint. And the recipe is really simple. You just add more nodes, and that's it, right? That's all there is to it with HCI. Just add more nodes. They're HCI, their solutions, these are purpose built to enable easy scale, which was kind of a significant shortcoming of legacy environments. Next up, we'll have edge computing, remote branch office. There's a lot of terms that describe this, but the needs remain the same, right? You got to have simplicity, scalability, and cost effectiveness. Okay. So in a traditional remote branch office sense, HCI is kind of a perfect fit since these hyperconverged clusters, they can start really small. So even the biggest enterprises, they've got small needs at the edge, right? You need these solutions to scale down to support these environments. So simple scalability, ease of use, ease of management, these are key. A lot of these edge environments maybe don't have the same resources or dedicated IT staff. So it's important that this infrastructure that's deployed to these locations, it's got to be rock solid. It's got to be easy to administer. It's got to be scalable. It's got to be quick to set up. So this is a really good use case for today's hyperconverged. Disaster recovery. All right. So data protection, disaster recovery. This is another strength of HCI today, thanks to easily scalable storage capabilities. So in recent years, like the term secondary storage, this has come into use to describe non-primary storage needs, including backup and recovery, as an example. So HCI, it can be a key enabler of secondary storage offerings, typically because of, easily harnessed and expandable storage footprint, but also, it's pretty central to all your workloads. Data protection is so important nowadays with the ransomware and everything that's happening out there. I mean, security is obviously key, and having a good DR and data protection plan in place is pretty critical. Let's talk about a use case that's not so great for HCI, right? Because it's not great for everything. So file storage, file servers, they're usually the dumping ground for everything that doesn't fit somewhere else. Unlike other workloads, file servers generally don't demand high performance. It's not really that critical. Hyperconverged is high performance by nature and contains high performance disks. So it's not that HCI wouldn't work, for file servers. It certainly would. It probably wouldn't be the most efficient use of your resources to run an HCI cluster strictly for file storage. Okay. So this is just kind of a bit of a recap on the things I just talked about. We'll get through these slides, and then hopefully, as Pono said, we can just kind of have a discussion. That's really what we're hoping for. So as I said, some of the advantages here, right? Really easy to size and deploy, really easy to manage for even the smallest IT teams. You get your, it's a bit cliche nowadays, but your single pane of glass, if you will. Really predictable to scale, right? Refresh cycles being as long as they are, organizations kind of have to guess how much they're going to need for the next 5 years, and you don't want to guess wrong on either side. But with HCI, it's much simpler, right? You can just add nodes as you go, and it's simple to upgrade back to one throat to choke, patch management, and it's pretty obvious. I've covered how this is going to help both your customers and your internal end users. For cloud-ready environment, what this means. Many organizations is to have kind of part of your application here, part of it in the cloud, and have the ability to migrate it easily. And how we accomplish that, we need to understand how to minister the architecture in the cloud, right? To be able to migrate them effectively. And HCI uses the same processes that you would in the cloud. So it makes those migrations a lot simpler. Okay. So let's get to the myths. Myths and myths busted, if you will. So we'll start with the challenges here. Applications not supported on early HCI versions. So early versions of Hyperconverged were a combination of flash and spinning disk, and there were performance challenges with IOPS, no doubt about it. In today's world, it's really rare to see HCI with spinning disks, so that challenge has been largely mitigated. Like I mentioned, back then, flash storage was exponentially more expensive than spinning disk, but today it's a lot more affordable, so we can just pay for the performance that we need. John will probably say it when he speaks up, but it's all about how much you want to spend and how fast you want to go, right?
To live by.
Yes, well said. So another challenge is, it may not provide the performance requirements for certain apps, for certain workloads. And John's words are key here as well. So technically, it's not so much a challenge as it's a question of cost, right? HCI by its nature, it's high performance. So the technology is certainly capable of handling sifting through big data and managing file and object storage. It comes down to a question of cost. Is it an effective use of your resources for this use case? And then that segues nicely into high performance computing. So this is a really specific use case. For those who aren't familiar, think like universities, like research at big universities, or government facilities. They'll take like really large data sets and they'll feed it into their HPC system, and it spits out an answer in the end. They're usually built on the cheapest boxes that you can find, to the point where if one of them breaks, you'll just throw it away and get another, right? We're talking the cheapest stuff you can get. Imagine if people know what a Raspberry Pi is, right? A little $40, $50 controller, a little board, and you can do a lot of things with them. Imagine 1,000 Raspberry Pis, excuse me, all daisy chained together, and they all work in parallel by slicing up a problem into 1,000 pieces, all at the same time, and then giving an answer at the end. Again, back to being HCI being a little cost prohibitive. Could certainly do this, but I want to stress, don't throw away your hyperconverged nodes, right? You throw your Raspberry Pis away, don't Don't throw your HCI nodes away. This is just a section where cost becomes an issue again. So the myths. So we discussed the expense. I think I've hammered it pretty hard here at this point. In the early days, HCI was more expensive than bring your own data center or converged infrastructures. As flash storage has become much more affordable, so has HCI. Another common myth that I'll hear is that it doesn't have the same range of capabilities that build your own data center or converged have. Either it's too resource intensive for the remote branch offices or the edge use cases, or it's just not robust enough for enterprise. And again, we're kind of back into cost prohibitive again. From a functionality standpoint, in the early days, HCI didn't have replication built in. As a matter of fact, no one really did. It had to be built in. But today it's just code. It's just code. So it's included. And ACI can function, extremely well in both edge, primary, and secondary site use cases. Feature parity. Boy, I feel like I'm getting awfully redundant here, boys. But replication is a standout for this myth. Okay, for feature parity, this whole issue with feature parity. In an attempt to keep everybody from falling asleep, I'm going to use snapshotting as another example that I could use here just to mix it up a little bit. So early days, build your own data center and converged. They evolved to have these features because of demand. Market demands, you got to respond, right? HCI did not have this functionality built into it from the start, and that rubbed people the wrong way, right? That you want to switch technologies, you want the same functionality in your new fancy HCI system as you had in your converged system before it. So technology evolves, the market evolved, and now the HCI has those features built in. Single vendor lock-in. So this myth likely ties back to the mainframe days where IBM, owned everything to include the software and the operating systems. So HCI vendors, today they strive to be agnostic insofar as what hardware, hypervisor, operating system, and software you choose to run on it. Right, that's typically touted. So this is kind of a myth that needs to be debunked, as well as this all or nothing myth. So the thought here being that you either must have everything in a hyperconverged architecture or nothing in hyperconverged. And the question typically comes up as, well, how do I go from my existing infrastructure to hyperconverged clusters? And it's really simple because HCI systems today, they allow the connection of existing storage, and it'll pool those resources just like it would with the storage on your nodes itself, right? So you can just kind of plug and play in that regard. It's just going to access them, pull them in, same pane of glass, rock and roll. Current issues, culture, guys. So it's a mind shift change that we're hoping to adjust, partially with this presentation and hopefully with the discussion that follows. It goes back to some of the early challenges and the current myths that we've discussed. People are naturally averse to change, and HCI is just capable of a lot more today, and it's just about getting that message out there. Legacy features not being available. So this is also a nice segue from that previous culture point. It's back to mind shift change. You might hear someone say, like, I like how Fiber Channel works. I already have my infrastructure deployed. I don't want to change all of that, too much work or what have you. But it's really pretty simple. Technology evolves constantly. And if you want to get the most out of your investment, you got to stay on top of your game. You'll get left behind. How many people today have the same cell phone that they had 4 or 5 years ago, right? HCI, really came into prevalence about 4 years ago, with a set of features, a specific set of features, but market demands, right, have caused those features to evolve and shift to include these legacy features that everybody was clamoring for. So ultimately, at some point, you got to stop the bleeding and catch up with the times, or technical debt is just going to pile up and bury you. And if, relevant for someone's organization, the competition takes advantage of it, you get left in the dust. And then file and object storage cost, already covered it. Certainly an issue if you're trying to run HCI nodes strictly for file and object storage. It's just not the best use of your dollars today. But as that requirement, if it becomes an industry standard, you can bet that it'll be incorporated into HCI. It's just an application after all. So market demand, right? Market demand. So last slide here, kind of covered like that real high 30,000 foot view here. Tried to keep things as business focused as I could and not too technical, because we got punch card John here for that stuff. Here's some examples of some of the hyperconverged vendors that are out today, right? You got VxRail, and certainly with our friends from Cisco here, we've got HyperFlex. Credit where credit's due. Nutanix, they invented this easy button. They brought this to market. They're making a shift nowadays into more of a less of an appliance offering and more of software. Their hypervisor Apocalypse is really what they're pushing for. And then of course VMware vSAN, and then you have the niche offerings, Pivot 3 and Atlantis as some examples. And we can talk more about those if people have questions. So that was kind of the intro to HCI here, guys. That was a 30,000 foot overview. I'm not sure if there's any, David hopefully is still catching on. If there's any questions at this point, next up, we're going to pass it over to John, and he's going to kind of take a high level view or a technical view as opposed to the high level view. But I'd love to take a break here and kind of get some thoughts, some feedback on what we just shared, that real, commercial airliner view of HCI. Maybe some of you guys have heard some myths or have thoughts on hyperconverged versus traditional architectures. We'd love to talk about it. We want to make this as engaging as possible. So please, if anybody has any questions, now's the time. And if not, John, please.
So we actually are getting some questions in the chat window. And again, if you'd like to jump on the stage to ask your question, there's a little blue button, request to share audio and video, and we'll bring you right up. There is a question. Reem asks, can you compare the benefits of HCI versus cloud SVS services?
That'd be my bet.
Yeah, Pono, you want to take this one?
No, we can.
Yeah.
There's more than two different things to consider, but basically the starting point is from benefits in one or the other. The starting point depends on what the application is, how large the application is, redundancy, security, etc., and then also what you have on site and what you physically have on site and what your capabilities are. So effectively think of it in these terms. If you're a fairly small shop and you only have a handful of applications, it doesn't make sense to try to run your own infrastructure. That would be a complete advantage, meaning cloud. That would be a complete advantage. If you were in a situation where you have a lot of test and dev test equipment, development equipment that you have to basically spin up and spin down, and you're not going to have it for a long term, that's also a good argument for the cloud. Conversely, if you're running, let's just say, enterprise level application with hundreds, thousands, tens of thousands of people accessing the application, and you have to have control to include security on it, generally better, and assuming that you have the facilities to have it on site, it's generally better. It's generally going to be more cost effective over the long term to run it on site. So really what I'm getting at is you have to take into consideration each application or group of applications, what you're trying to accomplish with it, how long it's going to be running, and how much money you want to spend, and then start going in either of the make the decision on whichever direction it is that you would like to go in. So there isn't really a one size fits all for everything. It is certainly a consideration. It's what John and I, for that matter, John and I spend a lot of our time doing, asking those sort of questions so we can figure out where the best place is to put it. Does that help? And I'm looking at the chat.
Yeah. So what I would say to net it out is, do you know every application that you need and every service that is included in that application? As a legacy application evolves, we back in the old days, we programmed everything into this big old chunk of code, right? We had the Washington Monument kind of code. Well, from that, we've evolved into, the minions kind of model, services, microservices, and we can deploy those, whether it be on site or in the cloud. Really, it comes down to, however, do you understand all the pieces that you need? And this isn't necessarily to cast aspersions on anyone. We're all in the same boat. I've been doing this a long time, and I've asked a lot of customers, do you understand what applications you have? How many mission critical or how many applications are you running? Well, I've gotten answers anywhere from more than one to usually I don't know, but typically when people will throw out some number just so that they don't sound like they don't know their environment. Part of the issue comes from how do those applications then interoperate? There are services in the cloud, database services, directory services, application types of services for microservice kinds of things, very specific kinds of applications that you can cobble together to address the need that you have for your user. Can I anticipate all of those, however, in the cloud? In the cloud, I have to, because I'm getting charged for every one of those guys. And I'm getting charged a lot for computer time, for storage time, for network time, for security, as Pono mentioned. All of those things all come in a monthly bill. When I have that on site, I can say, oh, this, we didn't anticipate this part of the application, but we'll just throw it on this server too, and it'll work. We'll throw it on this hyperconverged cluster too, and it'll work. You don't have to really be as aware of the types of services and the types of budget that you might have or not have for the cloud. And that's really the difference there. The other side of this, I would say, is administratively. For years, I've talked to people about this as well, that pick a way that you want to administer your environment. Am I going to administer my environment based on users? Maybe I worry about Active Directory. Am I going to administer based on networking? Maybe. I'm a switch guy. I'm a router guy. I'm all that kind of stuff. Everything's going to look like a networking kind of construct, or applications, or servers, or whatever it may happen to be. Pick one of those and have a consistent management strategy, whether it be on-premise or in the cloud. And that's what Ryan was kind of referring to on his slide a little bit earlier. Make sure that I can do the things in the same fashion without having to retrain and re-administer and reprocess when I move to the cloud. I've seen a lot of management by airline magazine. Hey, it's cheaper to go to the cloud. We're going to the cloud. Okay, what's that mean? And that's the point that, that was, the point of your question. And I think that's really the crux of the matter. If I know what I'm trying to put there and I know what the ramifications of that can be, then sure, I can go to the cloud. If not, I want to make sure I have that safety net, if you will, of something on premise that I don't have to worry about being a nickeled and dimed to death. Or as Ryan mentioned as well, hey, it didn't really work out in the cloud. I need to come back. Aha, the Roach Hotel. I'm coming back and I'm going to charge you to death for that. Just be aware.
Yeah, and I would offer also it's a good augmentation regardless for organizations who are trying to decide what workloads are going to the cloud, right? So hyperconverged software, like VMware, for example, or even Nutanix, it's deployed the same way in both, the customer's data center as it is in the cloud instances. So it runs on bare metal instances in the cloud, exactly the same as it does in the data center. So it's kind of the best foundation for companies if they're looking to build a hybrid cloud type environment. They can deploy the applications in their data center and then meld it with the public cloud. And since it's the same on both ends, you can have confidence that whatever you build in one will work in the other. I would just offer that as well.
Yeah, and I appreciate the remark there, Remy. One of the things that we just need to be aware of is, remember, hyperconverged is largely hyperconverged infrastructure. Application is a little bit different. Right, and it runs on that infrastructure. I'm not going to necessarily have a hyper-converged infrastructure in the cloud, although it looks that way because of the way that things are deployed and priced and charged. But the the real key is, am I running my application base and administering my applications in the same way, whether it's on-premise or in the cloud? And there are facilities to do that. There are facilities to check on how well things are running and how many resources are being consumed and move things appropriately, so that I can do that based on performance or based on billing or whatever the case may be. I can move an application around or a microservice around. And that's probably just as important as the hyper-converged infrastructure itself, if not more so. But I can talk forever about all this stuff. So
let's do it. Let's do it. I love this stuff, man. Let's go.
So some of you may recognize this guy. That's I started reading the Silver Surfer comic books, with episode or issue number 1. And anytime I tell anybody that, they always ask me, "Do you still have that? It's worth a ton of money." Back when these comic books were, I'll date myself quite a bit here, 12 cents. Try to get a graphic novel now for 12 cents, right? But back when these comic books were 12 cents, you read them and you threw them away. As a kid, I didn't think about what was going to happen in 30 years and how much something would be worth. I wasn't an archaeologist. I was a kid. So no, I don't have this comic book anymore, but it is, he's got the same hairstyle as me and kind of the same flavor, same skin color here. I'm a pretty pale guy. But anyway, this is my background image. Anytime you see this, you can kind of, reflect upon me. So
now, punch card John, I'm going to picture punch cards.
Exactly. So I'm going to drill down just a little bit more. Again, I'm from Cisco, so there's going to be a little bit of a Cisco spin on this. We tried very hard to make this agnostic, but I'll count on your comments at the end as to how well we do with that. But I always have liked this kind of idea of converged to hyperconverged. I started at Cisco when the converged infrastructure was first coming into the market. I started way back. I actually, did stuff on mainframes, and I did stuff on, large mini computers at the time, we called them, and then into distributed computing and all that. The punch cards are very real. As I moved into Cisco and we started talking about converged, what that meant was converging CPU, memory, and networking. Not really storage. Storage was still kind of a bolt-on. A good bolt-on, right? Because we had these applications or these products from other vendors, like an EMC, like a NetApp, like an IBM. All of the storage vendors wanted to be included in the Cisco converged infrastructure story. And not just Cisco, there were others out there as well, HP and Dell and IBM at the time. But it was still that silo. And that's what we try to get away from with the hyperconverged. Let's bring it all together. And again, just as Ryan said, I'll give credit where credit is due. Nutanix came out and said, hey, here's the easy button. Why should I have to have somebody that knows how to set all of this up, that knows how to create a disk group and create a LUN and create a volume and add networking and add a VLAN and add a private this and that and add BGP and all? Why do I need to have somebody that knows or individuals that know only that? We're still kind of locked into that silo information because database guys will never give that up, I guess. They're the smartest people in the world. But, it's just an application after all. A database doesn't run unless there's something underneath it. And I've spent my career having exactly that conversation with people. Okay, your application is the most important thing in the world. Yeah, it is. What happens if, somebody kicks how many times have you heard the story of the cleaning person that went into the data center, pulled out the plug to plug in the vacuum cleaner? That's a very real story in many occasions, not just, some isolated incident. That happens a lot. Not as much so more, now that we have badge readers and retina scanners and all that stuff, but it's a very real thing. Somebody doesn't recognize the importance of a piece of equipment and wants to plug in a toaster. No, we can't do that. But how do we move from converged to hyperconverged? And one of the things I've always been famous for is, hey, hyperconverged is great. I'm waiting for ludicrous converged. If you're a Spaceballs guy, you'll recognize that reference. So I kind of wanted to talk a little bit about, as Ryan was mentioned, in the early days, we had a first generation product. All of us did. First generation doesn't encompass everything. And so I kind of want to give you an idea here of that continuum of what's been happening along the way. And so, as I mentioned, first off, Data was distributed. We had a flash-friendly foundation because, as Ryan mentions, SSD was so expensive at the time. I'm not going to do everything on SSD. But how do I take advantage of that performance and then back it up with spinning disks that can be cheaper? And, back in probably 10 to 15 years ago, we started talking about tiered storage, right? I would have fast storage and I would have not so fast storage. I would have, it was kind of funny that we started at 7.2K spin RPM disks, went to 10K, went to 12K, went to 15K, kept waiting for that ludicrous converged spinning disk. At some point in time, physics takes over. You just can't go any faster and reliably read anything and do stuff. That's what we run into in a lot of things in technology, and people keep continuing to want that next level. And how do we address that? I'll talk about some of that as we go here. Again, the first iterations of hyperconverged, the biggest key was easy operations, easy install. We used to, in the early days of presenting the Cisco solution here, Hyperflex, we would go in and say, we can get you up and running in the morning in 4 hours, guarantee it. And we could, and we did, but we also needed to then train people on how to actually leverage and utilize the resource. But that was okay. Turnkey install. A lot of stuff was pre-installed. The stuff that wasn't the configuration piece that wasn't pre-installed, took a limited amount of time to get up and running, and you had a functional island of automation, if nothing else. Again, do I have to do everything in hyperconverged? No, I can address a single problem, or I can address a set of problems. I don't have to have everything on there. That's something that we've evolved with over the years that hyperconverged has been around as well. Early on, everybody was VMware, baby. There's still a lot of that 800-pound gorilla flavor of this as well, but everybody was VMware, and certainly we were as well. As you've seen, Nutanix has evolved into. I think that Ryan kind of had a mental lapse there, saying apocalypse. We would say that too. I appreciate that, Ryan. It's Acropolis, but we'd say apocalypse too. So, and again, part of this is I'm the Cisco guy. You're going to have to put up with some of this. But in any case,
that was a wink for you, John.
Acropolis, is the environment that helps you to get away from VMware. Over the years I've been doing this, a lot of people have talked about the VMware tax. Anybody ever hear that? Anybody ever say that? I want to get away from the VMware tax. I know I've said it a few times to customers. Do you always want to be paying to VMware? Well, everybody says, yeah, I really appreciate that. I understand what you're saying. How many people actually change? Not many. And why? Because they're the 800-pound gorilla, and they provide those services that people need. They make it easy. They make it easy to migrate from one to the other. Well, we would contend that ease of migration and that ease of operation is available now in lots of different platforms. And that's one of the things that you'll see here in the evolution of the hyperconverged platforms. We started, the easy button was good for a while, but then people, just as Ryan said, hey, I've actually got applications that need to run on this. Can you guarantee those? Are those supported? Will I be able to call, in Cisco's case, will I be able to call the Technical Assistance Center, TAC, and have them say, or be able to ask them, my SAP isn't running well. Why is that? In the early days, no, couldn't. We qualified some things, and largely it was because of the way Cisco works, we wanted to make sure that we had tested stuff before we told people that they could run it. That chasm of application availability was because we didn't have enough resources to test, candidly. As things got tested and we could feel good about being able to support them, we would include them then into these enterprise apps and the performance for those enterprise apps. We wanted to have data protection and native replication. It's all fine and good to have the easy button, but when it crashes, what do? Well, you want to protect that stuff and you want to be able to replicate that stuff. And one of the things you've been hearing here lately, how many times have you heard about the security breach, or somebody downloaded 1 million credit card numbers or social security numbers? Well, we want to make sure that you can't ever really prevent that. I have that conversation with my family and my wife a lot. Why would somebody do this? Well, number one, because they can. They want to show that they can. But number two is it could be lucrative, right? All you can do is put the hurdles in place. I have had this security discussion on many occasions. All you can do is put the hurdles in place to make it harder to get to your stuff and get anything valued than it is to get to the next guys. Because, security guys or hackers are inherently lazy. And so they're going to go off and, hey, it took me 10 minutes to get to this one. I'm going to go to the next one where it's only going to take me 2. And so you want to have security and encryption baked into your hyperconverged infrastructure so that yours is a little bit harder to get to than somebody else. And as Ryan mentioned, things have started moving, getting distributed again. The mainframe was the mainframe, the Godzilla in Ryan, or actually that was a Velociraptor, I guess, in the cartoon there that Ryan showed. It was the Tyrannosaurus Rex years ago. As I came into computing, we started talking about distributed computing and mini computers. That pendulum has swung a little bit even farther now that instead of having just a local environment, an on-premise environment, I'm going to have, the cloud, and I'm also going to have remote offices. But again, that consistency of administration and strategy of administration should, apply across all of it. And that's where we talk about edge and IoT and the ability to tie those guys back in to your main environment, to your production environment, using replication and data protection. All of that started getting baked into hyperconverged as well. Then we started doing multi-hypervisor, Hyper-V. A lot of our education customers say, hey, I get Microsoft for free. Well, there is no free lunch, of course, right? I mean, yeah, sort of, but, is it really? Yes, I understand what your perception is, just like an enterprise agreement. Hey, that's free. It's free until you true up, of course. But, I'm the technical guy. I don't talk about that kind of stuff. Multi-hypervisor was enabled in kind of the midlife, if you will, of hyperconverged. Stretch clusters. How do I make things even more available? I can, set up an environment where I have effectively a single cluster across a metropolitan domain. The data on one side is just as accessible from one side as it is from the other. And that's what a stretch cluster, we'll talk about that a little bit more as we go. Higher scale. We started out, most of the hyperconverged vendors had clusters of about 8 in the early days. We're up to now 64 node clusters very easily, with hyperconverged, with the storage and compute associated with it as well, and with the ability to stretch that across multiple domains in a metropolitan area. Higher capacity options, just as, hey, anybody still I carry around the punch cards. Anybody still carry around any floppy disks? I've got a couple of CDs here in my drawer that I could show you, but I can't believe it, but I don't have any floppy disks anymore. As those higher capacities come along, we want to take advantage of them. And we've done that certainly with the hyperconverged environment. Started out with 1 terabyte drives. We're up to now about 12 terabyte drives that are capable to be built into a hyperconverged environment. And multiples of those, of course, to get you an aggregate capacity for your environment. Excuse me. And then you see the multi-cloud piece. How do I address that again, as the platform and the administrative and the process-oriented component of my environment? Can I have that in multiple different locations, for a multi-private cloud, if you will? And how then do I apply that same strategy into a public cloud? And we'll talk about that a little bit as well. The new bright shiny object is Kubernetes and containers, K8S. Everybody heard of that one? I kind of, as you can imagine, excuse me, talking too much. As you can imagine, I harken back a lot to, I've been doing this for so long. Well, I was doing containers about 25 years ago. We called them zones at Sun Microsystems and Solaris. And now containers, I have a tendency of saying, oh, so that's new again. Okay, well, good. Let's talk about that now. Let me give you some background and some flavor around where that came from and what you're trying to do with it now. But the point of it is that Kubernetes and containers are available in the hyperconverged world as well. Cloud managed. Do I need to send somebody into a data center anymore? Not necessarily. I should have that application and, again, that strategy to manage from wherever and have that data available from wherever. Part of the whole idea of moving from a on-premise environment to a cloud environment is I don't have to go in and touch everything or be responsible for everything when it breaks. I can get that service level agreement, that SLA from the cloud provider that says this will always be up. Of course, they never say until it isn't, but there is always that case where something will happen. That's the Forrest Gump T-shirt, right? That says happens. But anyway, we have to work around those as well. And then more enterprise apps. And as we move a little bit farther, start looking at some of the new applications: machine learning and artificial intelligence, AI, ML. Everybody, sick of that one, buzzword bingo now. But it's everywhere. So get used to it if you're not. But what that gives us the capability to, or what that helps us to augment, is with a GPU, a graphics processing unit, that's dedicated to mathematical computations and computations in general. That I can leverage that GPU within a hyper-converged world and apply those resources and those operational cycles to a machine learning environment. All machine learning is going through a bunch of choices. I've got a billion things that I need to look at, and I want to find the one that makes sense to my environment. Really, it's that, again, that same idea of hyper-converged, but in the machine learning world. How do I get from here to here to here? And I can do that very readily and easily with machine learning, and I augment that with graphics processing units for the computational power. The only difference between now and 30 years ago when I was doing this stuff is that back then I had to turn a crank on the side of the computer to make it go faster. Intel turned that crank force a few times, and it's gone a lot faster. We've added now, that I can have 6 terabytes of memory. We didn't even talk about 6 terabytes of disk back then. But now, we had 6 terabytes of memory in one server. Think about that. And the speed of access to memory as opposed to punch cards or tape or remote disk. That's what, the evolution of technology has brought to us in this kind of context. I can now count on my compute infrastructure to give me the cycles to reduce that data set to this. We're going to improve some data protection, again, because after all, I've heard somewhere it's the data stupid. It's the economy stupid, right? But it's the data stupid. I don't run these computers to watch lights blink. A lot of people think that. A lot of administrators think that. I thought that. Right? I like this thing. I like watching those lights blink. But that's not why they're there. They're there for those applications and the data itself, and we need to protect that. We've added scale. We have made it even easier. We've added third-party types of availability, OpenShift Kubernetes, hardware acceleration. All of these things are part of that evolution that Ryan was alluding to, that it may have started out as a 1.0 platform. It's now much, much more than that. And we have to change our way of thinking from that, hey, it didn't do what I wanted it to do before, so I'm not going to think about it. Well, I'll guarantee you that it probably does what you want it to do now. And it's time to think about it, to get rid of that technical debt. And again, just some of the more things that are current or near future kinds of things. Secure boot, secure shell. I mean, all that kind of stuff. As the platforms evolve, as the market demands, we add these types of features in. And that's kind of the idea of this whole slide, is where we came from, where we are, and to some extent where we're going. Ryan kind of mentioned this as well, but the primary use cases have been traditionally virtual desktop infrastructure. That's kind of been the idea of converged computing from the beginning. That was the whole, one of the things that spun off of, and server virtualization is spun off of the success of VMware. I can have multiple machines effectively live on one machine. That machine could be a desktop, it could be some kind of application server, it could be whatever, but I can have multiples of those. Well, here I've been doing virtual desktop for quite a long time as well, about 25 years, and for the last 25 years, virtual desktop infrastructure, VDI, has been the killer app this year. Oh, VDI is going to be the killer app. We're going to go sell just tons of stuff. We're going to turn everybody into VDI. Well, yet again, it's the killer app this year. COVID has certainly helped to enhance that perception, because hey, nobody's not on site anymore. I need to be able to have a virtual desktop infrastructure so I can continue to operate as an operation, as an organization. And so maybe this year really will be the year of VDI. I'll believe it when I see it, but there's a lot of ways to make that happen, and a lot of ways to make that happen inexpensively and consistently. And that kind of bleeds over into VDI just being another application. It bleeds over into that virtualization question or proposal there. Server virtualization. Test and dev. If I can provide my guys with, here's a quick little environment for you to test everything that you're developing, don't test in production. It seems like an easy thing to say, but you'd be surprised at how many people don't. I hooked my production, my test environment to my production database because that's where all the good data is. Really? Did you realize that you just exposed millions of records here to some non-secure, non-locked down environment? But if I can isolate that environment and give the same capabilities so that I test things in test and dev and then roll them out to production, that's a pretty viable thing. And the cost and operational cost of hyperconverged has helped to encourage that. Large remote branch offices, simple deployment, centralized management, no fly and fix. I'm doing all this from the cloud. I'm managing all this from the cloud. And as Ryan mentioned, databases is kind of one of the last ones that came on. As it's not that things weren't supported; it just became a latency question. If it takes me 8 seconds to get something from a database, I'm going to the next site. 8 seconds. Are we that ADD? Yes, we are. If I have to do something in less than a second for it to be a viable user application. And so when I had infrastructure that didn't support that, i.e. spinning disk, I could do the databases, but nobody would use it. Now, as we start looking at SSDs for everything, all flash everywhere, then databases are a viable application as well. So one other sample application, as we were looking, those were kind of some of the regular ones, but Pono asked me to kind of talk about this a little bit. VDI solution sizing. So how many does it take to do a VDI? How many pieces and parts do I need? Well, this is just a sample, and again, this could apply to anybody, just the number of nodes. In the early days of VDI, we used to talk about the magic number was 100 users per server. If I could get to 100 users per server, I think that this is a viable solution. Well, one of the things I used to talk about with people is, okay, you got 100 users there, and you really are trying to cost engineer this environment. So you're going to put 100 users on one server. What happens when that one server goes down? Not that it will, of course, especially if it's Cisco equipment, we're perfect, nothing ever happens. However, those other guys, something might go down. Do you want to put that on one server? No. So I want to put it into a cluster, as you're seeing here. And again, I'm being a little facetious there with the Cisco part and the other vendor part, because we all use this kind of methodology. I'm going to put things in a cluster so that I limit my exposure. I may still have 100 users per server, but I'm going to have a couple extra in there in case something happens, and I can mitigate that load that's going to happen. And so here you see 400 seats and 4 servers. Those two things at the top are top of rack switches from Cisco, and so they're not part of the compute resource. If I wanted to add a few more, 150 in this case, I'll just add another server. 700, I add another server. And so this is just an example of the types of sizing that you can accomplish with the hyperconverged environment. And again, this isn't just Cisco, although we do it best, of course. I'm obligated to say that. But this is an example of how that sizing could happen. Think of about 100 users per server. That's kind of the magic number. So I want to talk a little bit about some of the differences between the different architectures that are out there. Some of the vendors for hyperconverged kind of have put things together in the context of older technology. Remember, we've talked about that converged infrastructure that had CPU memory compute on one node, and then I had a storage array, typically NetApp, EMC, IBM, Pure, pick your favorite, Tedgile, pick your favorite. I had those guys connected to my server farm. And when I administered those guys, I typically had to know how many disks are out there. Back in the way old days, I had to know how many tracks I'm going to assign on that disk, how many sectors and heads on that spinning disk am I going to leverage for this individual component of data? Well, that evolved into RAID groups. I'm sure that you've all heard of RAID groups. If not, it's just a collection of disks, redundant array of independent disk is what it originally stood for. But I would combine sets of disks so that I would limit the exposure of an outage of one of them. I would have RAID 0 or RAID 1 or RAID 10, which is most prevalent today. There were to address some of the cost associated with that mirroring, having two of each, to get half of that storage. To address some of the requirements or cost requirements of that, we came up with RAID 5 and RAID 6. I'm not going to mirror every disk. I'm going to have a parity calculation across a set of disks. What's that take? Well, in the storage days, I had a storage controller that did that parity calculation for me. In the hyper-converged days now, I'm drawing from the CPU, that single CPU that's being shared. I need cycles, again, no free lunch. I need cycles to create, calculate that RAID and to recover from a RAID outage, but I'm going to now force that onto the RAID controller or to the CPU as opposed to a storage controller. When I did that, that's the way that we've done things. That's what we were used to. That's how, again, that mindset for change that Ryan was mentioning, that's how we've always done it. So let's just continue doing that way. What's wrong with that? Well, as I start thinking about these larger disk capacities, back in the days when it was, disks were measured in gigabytes and a rebuild time was less than half an hour, that wasn't a bad thing necessarily. When I start looking at individual components of a RAID group in the multi-terabytes, and rebuild time might be in multiple hours or days, can I afford that exposure? That's the question. And so as I look at disk groups here, one of the ways that not only am I applying the technology from the 90s and before to my current hyper-converged environment, but I'm also exposing how I place those VMs and the relying that they have on disk groups and LUNs. So typically what I do here with the disk group is I have a VM, I store it on my local disk group. I have another VM, it goes on another disk group. I have another VM, it goes on a third set of disk group. Well, when I add that fourth VM, well, I'm going to share that first one. Maybe it's a round robin, maybe it's a random, but I'm not really necessarily balancing the performance requirements of that environment. In a distributed file system environment, I'm writing everything across every drive that's available in my cluster. And so when I add a VM, I kind of slice it up. We call it sharding. I've always loved that term, sharding. But now you know what that means if you didn't know before. Sharding is slicing up a piece of data. And so a VM can be sliced up, in this case, into 3 components and stored on each one of the nodes. I have a second VM, it gets sliced up and shared, or stored, I should say. I have a third VM, here you see the kind of the mechanism here. And I have balanced space utilization as one of the benefits I get out of this. I don't have a hotspot necessarily because I've got 2 VMs on one server. I can have multiple VMs on a server and not worry about having to get to that data through one access point. I can get to the data through multiple access points. And if that VM moves, I don't have to move the localized version of the data. I just access the data from the data store. That dynamic distribution, again, as I'm writing data in a conventional file system, I write it to the first server, and that first server then has the responsibility to replicate it to the others so that I have data protection. In the distributed file system approach, all the data gets written simultaneously across all the nodes, leveraging the cache of the SSD and the networking that's behind this. And so I write everything to that I only write it once, basically. And then I don't necessarily have to replicate, I write it once, it's already done. The big key to this is, when can I respond to my application that my write is complete, right? That's when it's really done. when can the application move to the next step? Once I get that acknowledged that things have been written consistently, then my application can move to the next step. We contend that it's easier to do that in a protected fashion in a distributed file system methodology than it is in a local file system methodology, a disk group methodology. So there could be some instances here. What this is showing is I have some number of VMs here, and in a distributed file system methodology, I have consistent latency throughout. No matter how many nodes, no matter how many different file systems that may be, or excuse me, applications that may be out there, I have a consistent latency and consistent performance across all the VMs in the cluster. With disk groups, I may have a little bit faster in some occasions, but I will probably have slower in just as many occasions. Think about that application that Ryan was referring to, that mission critical one in a database. Do I want sometimes my SQL queries to come back in a second and sometimes 5 seconds? No. I want to have consistent response and consistent latencies that my applications can depend upon. And that's part of the difference of the architectures. We should also be including, however, some of these services that save us some money. Years ago, we started talking about in storage, the virtualized storage, or that I'm not really, when I ask for a terabyte, I'm going to tell you you've got a terabyte, but I'm only going to allocate a megabyte. As you need it, I will continue to grow it, but I can tell people that I've got 5 petabytes of storage capacity, when in fact I really only have a terabyte. I have to be aware, as the storage administrator, having that hat on, I got to be the storage administrator that says, I know that I'm watching this, and when it gets close, I'm going to add storage. I'm going to add real storage. No, really, I will. I won't ever miss that opportunity until I do, but I won't ever miss that opportunity to add storage. Well, one of the things that we've started baking in here was, anybody ever go off and do deduplication on your Windows environment? You go in and click on your C drive and say, go in and optimize this guy. What that does is deduplication. Typically, it's not done in line, although it can be in a scheduled fashion, but typically it's done on demand. Or if it's scheduled, it's going to take resources one way or the other. Or compression. I'm going to go off and all those emails that I have out there that are all character-based, I'm going to compress those guys. I'm going to go from, we hear people talking about 20-to-1 compression and deduplication for storage efficiencies. Some of that is always, your mileage may vary, as far as how much improvement, or savings that you get from compression and deduplication. But the point is, I should be doing this all the time. I should be doing this all the time without impact to performance. And with the idea of a log structured file system is that's more efficient to do that. I'm doing that across all of my environments as opposed to a disk group at a time. No special hardware, no performance impact, because it was coded from the beginning into the environment, as opposed to, well, I know how I run with a RAID controller and this is what I need to do. No configuration lock-in and no additional license. So let's change gears a little bit. That was kind of what are some of the technologies that should be available in your hyperconverged world, and what are the differences in the architectures. And it's okay. I mean, we contend that, of course, that we have the best architecture. However, the other guys are pretty good too. Well, it really comes down to,
can you hear me?
Yes.
Okay, pause for just a second there. As a heads up, we're just about 10 minutes out from the end of the session. And no, that's okay. And so what I wanted to do was, I figure we can do this one of two ways. Q&A. Any questions obviously can go into the chat room, one, or two, if somebody wants to come on and video and ask questions or have a little bit of dialogue, now is probably a good time to do that. If nobody jumps in and or sends puts any questions in there, we'll just continue through the remainder of the data protection piece, and then we can just wrap up. Okay,
yeah,
go ahead, John.
Just this one slide will effectively cover most of what I would be talking about in the data protection piece. What you really have to consider in data protection is, what is your recovery point objective, RPO? and what's your recovery time objective, RTO. And so you see here this continuum from 0 to 5 minutes to 24 hours, near 0 to 24 hours, and the different types of environments that you need to consider to address each one of those requirements. So if I have stretch clusters, that kind of gives me that 0 RPO RTO. If I'm doing snapshots and replication, I can have 5 minutes to 24 hours. And if I'm doing I have third-party products that give me that flexibility that I'm not locked into a vendor particularly. I can do different types of things that include the cloud. So that's kind of all that I would. And again, with all these slides will be available as well. I apologize, I get into war stories and things. So, but yeah, I agree with Pono. Let's make sure that this is your session.
All right, thank you. Anybody want to jump in insofar as video and audio? And I'm watching the chat. I don't see any questions there that we haven't covered already. And as a note, Ryan had to step away for just a moment, so I'll keep running here.
What you'll see when you get these slides are the things that I've shown already. Here is some specific considerations for replication and the things to think about in your environment. It should also be simple to use, and we can talk about that. The types of workloads and what that means, but I wanted to get to the slide on stretch cluster and specifically this guy. Stretch cluster sounds cool. Oh, active. I've always got availability of my data. Well, yes, you do, but you also need to be aware of the constraints as far as that interconnect that's required between all of your sites. And that witness server that's also required not on one of your sites because it needs to be available no matter whether one of the sites went down or not. It has to be able to be that traffic cop or that voting member that says, you're the master, you're not. And that's what the witness server does. And so, again, you'll get these slides. These are the types of considerations to think about. The last thing, the last thing I would talk about here would be, as we've talked about the SSDs and how expensive they were in the initial implementations of hyperconverged, and why we backed them up with spinning disk, how we evolved that to have the preponderant environment today is all flash. We've now evolved that as well. As technology, as the market has demanded, we wanted it even faster. And so we now have available, and the industry now has available, all NVMe drive options. What's NVMe? Well, NVMe is closer to the CPU. When you think about how far that data has to travel, think about CPU and cache on that CPU is the fastest. I've had people kind of characterize this as that beer that's in your hand during the football game. I have that beer right there. It's in cache next to my CPU. I have typically level 1, 2, 3 cache, which is steps.
Is John that we lost, or is that me?
Let me see here. Did you lost me? Am I not talking?
No, I can see you, John.
Okay.
Pono, your video seems to be gone though. With this, I have a question.
Yes.
With the situation, let's say somebody's migrating from, on premises, and they're looking at this as a potential option. How hard is it for somebody that's managing their system as is, their infrastructure, to get trained up and be ready to use this compared to a virtual machine setup with their server clusters?
Let me take that one. So I'm going to speak specifically. To our experience, meaning from a HyperFlex standpoint, although it's a general statement across most of the hyperconverged. And I'll use a specific example. So John and I cover state, local, and education. And the example I will use will be state of Washington, Ledge Tech. Last year, they bought a cluster. The idea was to take their converged systems and retire them because they were sunsetting. From the time that the systems, not so much delivery, right? It's delivered, et cetera. From the time that we showed up on site to start the process until the time we had them trained and migrating off of their existing systems onto the new system was 2 days. 2 days. That's the full setup. That was training them, and training is not that complicated. The reality is the software that manages the hyperconvergence it's kind of a set it up and don't touch it until you have to do something to it again. For example, add another node. So that training was very short. The reality in their case was they were working through vCenter. You're still managing through vCenter. It doesn't matter. And then they just had to start migrating workloads over. So the answer to that is incredibly short in comparison to what we've been accustomed to in the past. And it's the same sort of situation when they do upgrades. You know, as somebody's trying to scale up, you throw another node in, hit the button, off it goes. Does that help? David, I think we lost you. Either that or I lost everybody.
Still there.
And now I can't hear anybody. Ryan. Oh, there you go. I can hear you, Ryan. I see you, David. So yeah, did that help?
No, that's great. That yeah, thank you.
Oh, and keep in mind, most of my customers, you know, from a technical resource standpoint, I'm not suggesting that anybody has excess technical resources, but the reality was they were responsible for an environment with 1,000 people in it, and there were only 3 of them managing the entire environment to include the desktop. So they didn't have more resources, which is part of the logic and why they went in this direction.
But part of what you see
Any
here,
more questions?
what you see here then is that I'm not having to go to the
Am I muted?
I'm not having to go to
I can
the
hear you, Bono.
Okay.
I'm not having to go to the network guy. I'm not having to go to the applications guy. I am the infrastructure guy. I create volumes very easily, like I'm used to.
Are we waiting?
Can you not hear
Check and
John?
see if there's
Pono?
any. Oh no, I can't.
Oh, sorry, John. Go ahead. He was.
Anyway, I'm managing storage in the same fashion that I've always done within VMware, just as Pono mentioned. You know, I go off and create volumes as opposed to going to the storage guy and say, hey, I need a RAID 6, you know, disk group with this, that, and the other thing, and present that to me. You know, as a VMware guy, I look at it and say, I just need a volume. I'm going to go create another volume of 500 gigs or a terabyte or whatever the case may be. So it's a lot easier in that context, and the migration of it then is a lot easier as well.
Thanks, John. Do we have any other questions? Again, feel free to hit the button or ask it in chat.
And I like that Ryan likes sharding. So if I'm known for anything, it's Punch Card John and sharding.
Yeah.
Thank you.
Yeah, those are good claims to fame, man.
All right. Well, I guess we'll wrap the session up. There are some networking rooms available in the sessions over on the left-hand side. If you're feeling adventurous, there's also a networking button that's included that will randomly match you with other folks here today. I saw Ryan's eyes get big. So, yeah, please feel free to join us and explore this a little bit. We're going to be using this platform and testing it out. We're going to have another Spark series on September 30th, actually. We have some folks from Microsoft, actually, and some other ones coming in to discuss kind of the trends of technology in healthcare specifically, which I imagine there's probably going to be a little bit of overlap with some of what we talked about today, too. But yeah, mark your calendars on that one, September 30th. We haven't put it out yet, but it will be coming shortly. So, and with that, feel free to join me and my cat that's just jumped up on my desk over in the networking section if you'd like to.
Thanks, everyone, for joining us. We really appreciate it.
Nice.